Okay, chapter 7, day 1. What we're going to focus on in this chapter is all about linear lines. And we're going to start out with how do we find the equation of the best fit line for a set of data. And then with that, we're going to be able to write things like slope and y-intercept in context. So, let's take a look. So, we're going to see some abbreviations in this chapter. The first one is called LSRL, and that just stands for the best fit line. It also is called the linear regression line. All of those words have the same meaning to it. So if we say find the LSRL, or find the best fit line, or find the linear regression line, we're talking about the same thing. And what we're talking about is an equation that looks like this. Y hat equals A plus BX. Now, you might have seen it written Y equals MX plus B in your earlier years, but we don't use MX plus B because the rest of the world doesn't use MX plus B. We use A plus BX. The hat is on there is because it's what we use to it signifies we're going to be using this equation to help us make predictions. So we read this as Y hat equals the A, which is the y-intercept, plus the B, which is the slope, and then X is just the other variable at the end. If the slope is negative, then we use a minus sign in the middle. But there's the equation, Y hat equals A plus BX. Now, we're going to talk about slope and y-intercept, and then we're going to talk about how did we create the equation. So, slope in context. This number is the slope, but what does it tell us? Here's what it tells us, and here's how we say it. What we're going to do is we're going to say, for every 1 unit increase, always every 1 unit increase in the x variable, whatever this is, the y variable, whatever that is, will either increase or decrease, whether the slope is positive or negative. It's going to increase or decrease by whatever that slope value is, and then whatever units we're working with. That's slope in context. So let's look at an example that I made up. So here's an equation. You know, some people say, oh, you go and get really good grades, and if your grades are good, you'll make more salary. So here's an equation that someone came up with. And they said, the predicted salary is $50,000 plus 2,400 times whatever their GPA was in school. So here's the equation without the words. Y hat equals 50,000 plus 2,400 times x. So slope in context. Well, what are we going to say? For every 1 unit increase in x, well, x is GPA, and GPA is measured in points. So for every 1 point increase in the x's GPA, the y, which is salary, will increase. I know it's going to increase because the slope is positive, by $2,400. Because that's the units that we're working in. $2,500 or $2,400. Okay, that's slope in context. For every 1 unit increase in the x, the y will increase, because that's plus, by the number, the units. Y-intercept. Well, I think you learned in earlier grades that it's when the line hits the y-axis. It's when the line intercepts the y-axis. But for this course, we're going to put a little more meaning to it. It's when the x variable has a value of 0. The y variable is whatever the y-intercept value is in its units. So we state that by saying when the whatever the x variable is has a value of 0, the whatever the y variable is has a certain value in units. So let's take a look back at our salary problem again. Okay, so here's our problem. Now, again, the slope is next to the x, the y-intercept is the 50,000. So, y-intercept in context. When the x variable, GPA, is 0, right, when it has a value of 0, the y variable, salary, will be $50,000. I'll just do dollars. Okay? So, that's an example of slope and y-intercept in context. You might say, well, where'd you get this equation from? Well, it's an equation that I made up and generated with the calculator. And let me show you how to create the equations on your calculator. So, for your calculator, to create the equation, you're going to get data. And what you're going to do is you're going to put the data into list 1 and list 2. Earlier this year, we took information and we calculated, and we only put the data into list 1. Well, now we're going to put it into list 1 and list 2. So if this is my calculator, all right, it says I have to hit stat, then hit enter. So I'm going to press stat, then I'm going to press enter. And I'm going to put my data into list 1 and list 2. So if you remember, we go up, clear, and come down to clear a list if you needed to. I'm going to put the numbers back in for this problem though. So 0, 1, 2, 3. I just have a little example here. So I put my data into list 1 and to list 2. I put my X stuff in list 1 and my Y stuff in list 2. Now, after the data is in, you're going to press stat, you're going to arrow over, and you're going to go to option number 8. So after the data is in, you're going to press stat, you're going to press the arrow key, and it brings us to that same menu we had last time when we chose option 1, but now we're going to choose option 8, which is linear regression, a plus bx. It automatically puts the x list and the y list, what we want in there. So, what are we going to do? We're going to hit enter a few times, right? Because here's what my screen says. Just keep hitting enter. Okay? So I'm going to keep hitting enter. Enter, 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 enter. And lo and behold, it gives us an answer. Now, this answer that it gives us, let me just move this up, tells us some things. So here's the answer that came out onto my screen. All right? The A is the y-intercept. The B is the slope. So, y equals a plus bx. The A off the calculator is the y-intercept. The B is the slope. And the correlation that we talked about earlier, that is the R value, and it will also give you correlation. Now, in this phony baloney example, the correlation is 1. It's not always 1, but for this example, it came out to be 1. So, we take this information and we write an equation. And again, the equation is y equals a plus bx. A plus bx. Y equals. So, y equals a, we just put 50,000 where a is, plus because this is positive, 2,400, and then the letter x. And that is an equation of the line that best fits that data. And that's how you get the equation from your calculator. And that's what we're going to open with here for Chapter 7.